Hello, this is our circuit project for our class ECEN 101. My name is Madden. My partners here are
Mallory.
And Kendall Maxwell.
okay. And so we're building an agenda, and our project consisted of several things, such as building the circuit, initial observations of it, forming a hypothesis, our experimental results, and comparing to Ohm's law that we learned in class, which is voltage is equal to current in amps times resistance in ohms. So starting with building a circuit, for our project, we got ISCO basic circuits kit. It included two D-cell batteries, a knife switch, and two light bulbs, and about 120 inches of wire. I think it's 18 gauge. In order to get our results to compare with Ohm's law, we needed to have several configurations of our circuit, whether that be series or parallel circuits, or having one or two bulbs, or having two batteries attached, and other things in order to see how the measurements changed. So some initial observations. Uh, a lot of the circuits brought up problems for us, like it not working or having to strip the wires in order to connect them and get an accurate reading, or figuring out how to connect the wires to the circuit. Like with the knife switch, there are little black knobs that you need to unscrew and then attach wires under there in order to get a proper connection for the knife switch to work. And then we also had to use multimeters in the classroom in Cherry Hall in order to measure the current and voltage and resistance of all of our circuits. For my part, I did four configurations of the circuit. Case one being when there's one bulb and one battery connected to the circuit, and the light was dim, as in not bright, but it was on. Uh, when one bulb and two batteries are connected to the circuit, uh, that's when the circuit was the brightest out of any other case, because it had 3 volts running through it instead of just 1.5, and each battery has 1.5 voltage. When two bulbs and one battery are connected to the circuit, both light bulbs do not glow almost at all unless you're in complete darkness, which shows that electricity is still running through the circuit, but it's not enough to power the bulbs. And when two bulbs and two batteries are connected, which glowed similarly to case two, where the light was not very bright.
Forming a hypothesis. So this is based off of parallel and series circuits. For the current in series circuits, the current is the same through each component. In parallel circuits, the current splits, with the total being the sum of the current through each branch. For the brightness in series circuits, the brightness decreases as more bulbs are added. In parallel circuits, the increases as more bulbs are added. Piecing and building the circuits together, it has to be precise or the circuit won't function properly or produce accurate results. For series circuits, voltage, if more resistors are added to a series circuit, the total voltage drop across the circuit will increase. For the resistance, the total resistance of a series circuit is equal to the sum of the individual resistances. For parallel circuits, the voltage drop across each component in a parallel circuit will be the same. For the resistance, adding more resistors in parallel will decrease the total resistance of the circuit.
Experimental experiment results. Our group found that in each case, our experimental measurements were consistent with the Ohm's law equation: voltage equals current in amps times resistance in ohms. Here are some graphs and information from one of our experiments to provide a visual representation. Even in the theoretical findings, Ohm's law stayed true. The current and voltage are found to have a consistent and congruent relationship, regardless of whether our measurements of each section were higher than the estimated theoretical measurements. The bulbs also glowed as anticipated, with the 2 bulbs, 1 battery circuit, or in case 2, glowing noticeably less than any other because and in case 3 was the brightest as it had the highest voltage and least resistance, therefore giving the current much more leeway to flow any of the other cases.
Comparison to Ohm's law and final conclusions. So the final conclusion is series circuits have single path for current, and the current is the same through all components. Parallel circuits have multiple paths for current, and the total current is the sum of the current in each branch. The brightness of a bulb is related to the current flowing through it.
And also, in these pictures depicted is series circuits, where how the circuits are arranged, uh, adding to his points that they have a single path and the current is the same through all of them components, which is why the bulb in case 3 is brighter than the bulb in case 1. And something that I learned from this project was that building circuits is not easy, and I did not know that there are wires that we have and you have to connect with multiple pieces and making sure that all of the metal touches at every point in it. And I also didn't know that you can measure current from the metal parts on the devices themselves and how to use the multimeter.
So for what I learned that parallel circuits are used in everyday life, such as cars, um, houses, phones, computers, laptops, anything that basically you touch, it's a parallel circuit. And I learned that in order for a circuit to truly work, you have to piece it together correctly, or it won't come out with the accurate results that you want.
Um, the one thing that I learned from this experiment is that always test your batteries before trying to put together a circuit, because I put together my whole circuit and then I realized that the batteries in my kit didn't even work. So I had to buy brand new batteries. And another thing that I learned from this experiment is that parallel circuits are um always in our everyday life. For example, my room has parallel circuits because in the beginning of the year, my ceiling started leaking water and only 2 outlets in my whole room worked, and all 4 of the other ones didn't because water only messed up those ones, but the last one worked because the circuit wasn't affected by the damage due to its alternate like power source and like flow of energy.
Okay, thank you very much. This is our presentation for our project. Uh, bye-bye.